My name is Jacob Biquette, and I'm president of WMU's American Foundry Society chapter. This is the final product of months of work, of an entire team of people coming together as a community to create. It's shiny, but there's more to it. It all started with a challenge, to build a spear, honoring the traditions of the people of Africa as to the extent our knowledge and capability would allow. To do this, one of our members, Xavier Berger, took a close look at the rules, historical data, and came up with this design. Drawing a spear, however, is only the beginning. To make this, we would first have to make a mold. With no CNC support available, we took the ham material to my father's woodshop and proceeded to use our heads and brains to make the geometry as close to the CAD model as possible. Here, we are squaring the mold halves and drilling the bolt holes that will create dimensional consistency throughout the rest of the process. Here, we're using a 1:1 scale printout of our CAD drawing to locate the blade on the mold and score its outline. We then used carpenter's chalk to mark the outline. Bolting together and flipping the mold transferred the image to the other side, after which we scored it as well. After this, we had two identical mold halves. The next step was to create the center spine of the blade. We created the jig seen here to enable a router to cut into the material at an angle by shimming the mold under the jig to the exact angle called out in the CAD using a digital inclinometer. After that, we used another specialized jig to create the rear shank and inclined radius in the blade. All that was left after that was to use specialized wedges with angles matching the blade cross-section angles, covered with sandpaper and a guide block to sand in the triangular form of the blade halves. And then we had a mold. To be sure we had been accurate, we passed an inspection camera into the mold and ensured cope matched drag. They looked great. After this, we took the mold back to school and installed our downsprue. Our downsprue was attached, and then we were ready to go. After all this work, we had a mold ready for pour. Here we are at pour day at our industrial partner shop, Shellcast Incorporated. Many thanks to Bob Johnson, president of the company, for helping us out. As you can see, the pour got pretty spicy. The bead on the downsprue mold box junction failed, causing steel to cascade out of the mold once it had filled to that level. Luckily, the blade filled completely. Once we had our part back in the shop, we ground off the portion of the downsprue that had filled and got to work in getting a collar attached that would act as the common structure holding the blade to the spear. To do this, we heated a piece of round stock bored out to the diameter of the spear shank to red hot, and then placed it onto the end of the spear. We then heated both together until they were red hot and forged them into one piece. After that, we quenched the blade in oil to harden it. Metalwork now done, it was time for grinding, polishing, and initial sharpening. The finishing touch, putting the spear onto the handle, was unfortunately lost to history. We simply glued it on with some JB Weld for extra support. We drove pins through the collar and handle for extra security, and added string at the optimal hand position for comfort and to increase hand friction for sturdy holding. After final polishing, we had ourselves a spear we could be proud of.